Hello everyone. So today we are going to solve this POTD of lead code. The question is sorted search in the rotated sorted array 2. Okay. So what we have, there is an integer array nums sorted in non-descending order. That means not necessarily. Okay. That means we have an integer array that is sorted in non-descending. That means in ascending order, but there can be non-distinct values. Okay, for example 0, again 0, now 1, 2, 3, now again 3. Okay, like this, and now 5, 6, and let's say 9. Now okay, before being passed, the function nums is rotated at unknown pivot index. Okay, at index unknown index, it is rotated such that the resulting array is, for example, 1 0 1 2 4 4 5, and after that 6 7. Okay, this one is the normal array, and that can be that can be rotated at pivot 5. So we have 4 5, after 4 5, sorry 4 5 6 7, yeah, after 7, see, after 7 we got that it has been rotated. After 7 we have rotation. Okay, now given the target nums, given the array after the rotation of the integer target, return to okay. Given the array after the rotation of the integer array rotation, add an integer and an integer target, return 2 if the target is in nums, or else return false. Okay, yeah, so we are given the integer array such that the resulting array, okay, it has been told that nums has already been rotated. We don't need to rotate it. Okay, it has been already passed in our parameter as a rotated array. Now we are given an integer target and we have to find if it is present or not. For example, take this 2560012. The target is 0. Now target is 0. So 0 is present. Yeah, 0 is present, so it will return true. Now if we have 2560 and target is 3, so 3 is not present here, so it will return false. Okay, so let's take this example. Okay, let's take this example and we'll check what is our intuition. uh, Sorry, we have 256 256 Okay, now 256 and their indices are 0 1 2 3 4 5 and 6. Now, and target is 3, target is 3 target is 3. Now uh, we'll check where the at which index the rotation occurs. Till here 2 5 6, it is non-descending order. Okay, it means it is descending or ascending order. After that we see this element is less than this one. Okay, so we have to find the pivot index. Now. Okay, so we will take this one as start. Okay, this one is our start element, this one is our end element. Yeah, I will check middle. What is middle? Middle equals to start plus end by start plus end minus start by 2, means 0 6 by 2 equals to 3. So this one is our middle right now, and we have got the middle, and we will check if middle element is greater than or equal to previous element. sorry, 0 is greater than or equal to 6. No, it is false. That means 0 is strictly less than 6. That means here the transition occurs, means at after this position, at middle position, the transition occurs. So middle is our pivot. So middle is our pivot. So we'll store pivot equals to at index 3. Okay, we'll take another variable called pivot and we will store this index. After that, let me think what we'll do. After that we will check target value. We will check the target value. Where is the target is equals to 3, and is 3. Okay, now we have to check where is 3 lying. Now we have to check is 3 lying in this position, in this array or in this sub array. Okay, so yeah, we have got the pivot index. So here we can apply binary search for descending array, and here we can apply binary search for ascending or array. That binary search is very simple. Okay, here we will apply simple binary search, and here we will apply simple binary search for descending array. Okay, now we will make two conditions if start is less than end. Okay, for this one start is this one and end is this one, and for this sub array start is this one, end is this one. Now we will check till here. After that, if pivot is not found, we will check in this sub array. Yeah, that will work. Let's check the another example, 2560012. Okay, 25600 0012, and target is our 0. Target is our 0, 0, 1, 2. Okay. Let me try run this one. Okay. First we'll check here. Start is here, end is here. Start plus end by 2, end by 2, 2 by 2, 1. Here is our middle element. Now we'll check if 3 is greater than this one or less than this one. Yeah, 3 is less than. So end will come here, end will come here. And now we will check, is 3 present? No, 3 is not present. So this condition is not satisfied. So we'll go to this array, this sub array. Now start is this one, end is this one. So middle would be 3 plus 6 minus 3 by 2. That is equals to 4. So our middle will be here. Now we'll check 3 is greater than this one. Yeah, 3 is greater than this one. Then start will come here. Okay, start will come here. Now okay, start will come here. Okay. So what will happen? Now again we'll check if 2. Okay, one thing I said wrong, that here also we will apply increasing binary search. Okay, here also it is increasing, it is not decreasing. Here also increasing binary search, not decreasing. Here also decreasing, increasing. Here also increasing. Okay, now middle will be 5 plus 6 minus 5 minus 0 is to 5 by 2 equals to, sorry, it will be it will be 5 only. So middle will be here only. I will check is 3 is greater than, yeah, 3 is greater than, the start will come here. Now again we'll check. So it is not satisfied still, but we have reached the last index, so it will return false. At last it will return false. It will return false. Now we'll check here. I will check first we'll check where is the transition point, the pivot index. Okay, so what we'll check, we'll have this one as our start and this one as our end. Let me change the color. We have start here, end here. 0, 1, 2, 3, 4, 5, 6, again 6. So 6 by 3 here. Here is our middle element, and at first only we got the transition element, this one. Okay, this one is not greater than, so this one is our pivot index. This one is our pivot. Okay, so we will search at this index first. we didn't got, then we will return to this index, and at the starting only we'll see 3 plus 6 by 2. Okay, 3 plus 3 by 2, 1. Middle is our 4. We'll check here. I will check. Middle is equals to 0, so we'll return the middle, means, or we'll return true. Okay, so let's code it up. What we need a pivot index, and pivot equals to 0, and we have start and end. Start and end, and start equals to 0, and end equals to nums dot length. Let's take n. Okay, and n equals to nums dot length, and we have int start equals to 0, and end equals to n minus 1. Okay, end equals to n minus 1. Now start got, end got. Now yeah, I will check. While start is less than equals to end, we'll check middle. Okay, we'll have the middle element, so int mid equals to start plus minus start by 2, and then we will check if middle is greater than equals to 0 or not. Okay, if where is the middle? Yeah. Okay, let us check one more condition. If we have 2, 4, 9, 8, 7, 0, 1. Okay, now here we have the transition point. So start is at 0, 1, 2, 3, 4, 5, 6. Okay, again 6 elements. So this one is our middle element. We got that middle is greater than equals to, the previous element. Okay. Yeah, so we will do start equals to middle plus 1. Start equals to middle plus 1. Start will come here. Now again our new middle will be 1, 5. Okay, this one is our middle. Okay, now we'll check is greater than 7. No, then this is our pivot. We'll assign this one as our pivot. Okay, so we'll do this. Okay, yeah. If nums of middle, if nums of mid is greater than equals to nums of mid minus 1, if it is equals to this one, means if it is mid is greater than equals to 9, then we will do start equals to start plus 1. Yeah, start equals to start plus 1, and we'll check if else we'll put end equals to mid minus 1. For example, if we have this array 0, let's say not 0, sorry, 9, 8. Okay, after that we have the transition point, let's say 0, 1, 2, 3. Okay, and again take one more 4, 0, 1, 2, 3, 4, 5, 6, again 6 elements. Yeah. So again this one is our middle element. We'll check if this one is greater than this one. Yeah, this is greater than this one, so we know that transition point cannot be here. Okay, one thing. Okay, if this one is not equal to this, here also this one was greater than 9. 8 was 2, 4, 9, 8. So what did I do here? 9, 10. 10 is greater than 9. Okay, 10 is greater than 9, so we move start plus 1. 1 is greater than 0, so we'll move start plus 1. No, what we have to do, we'll search linearly, I guess. Yeah, linear search. We'll go linearly, and we'll see this one is greater than previous. No, this one is greater than previous. Yes, this one is greater than previous. No, so we'll got the pivot. Okay, sorry, we did very wrong here. So we'll do for int I equals to 0, I less than and I plus plus. If we get, if I is greater than 0 and nums of I is less than nums of I minus 1, then we got our pivot equals to I. Else if we got pivot equals to I, and we'll return. Okay, and we'll do fake. Okay. Now if we get, yeah, that's the only one condition we need here. Okay. Now we'll run the, now we'll do what we'll do. Now we will do this thing. Okay, we got our pivot. So pivot for first sub array, pivot is our end index. Okay, sorry, pivot minus 1 is our end index. Yeah. Okay, so int start equals to this one, end equals to this one. We will do update our end to be end equals to pivot minus 1. Okay. Now now okay, what if we got one thing I forgot, else pivot equals to 0. For example, if for example we have 9 and then here transition occurs 9, then 1 2 3 4 5. Okay, so we have 0 1 2 3 4, this time 5 elements, sorry, 5 index. So we have, if we check for this one, I is greater than 0, yeah, 1 is greater than 0 and 1 is less than this one. Okay, this one is greater than 0 and 1 is less than I minus 1. Okay, less than I minus 1. So this one, okay, this one is our pivot index. Okay. What if we got 0, or let's say, no, it is correct, okay. We don't need this one now. Now we'll run for start equals to 0, end equals to pivot minus 1. Now we'll check while start is less than equals to end. We'll check if normal binary search int mid equals to start plus start by 2, if nums of start nums of mid equals to target, so we'll return true. If nums of mid is less than target, that means this one is mid and our target, this one is our mid and we have our target here, so we'll do start equals to mid plus 1. Okay, so we'll do start equals to mid plus 1, else start equals to mid minus 1. Okay, sorry, end equals to mid minus 1. Okay, now if we got true, it will return directly true. Okay, and again we need to run for the next. Okay, from pivot to end, we ran this one from 0th element to the pivot minus 1. See, pivot minus 1, and now we need from pivot to the end. Okay, so now we have start equals to pivot and end equals to n. n minus 1. Now we'll do the same thing. Okay, if start is less than n, mid equals to start plus n by 2, target then return. Okay, at last we'll return false. Okay, I think that will run, and let's check. Okay, we forgot to do the dry run. Okay, yeah, at one time only it's running. See, feels so good. At first only it ran. Yeah, see 100% of the users. Nice. Come on. Okay, so that was all. I think you got the intuition how to solve it. Okay, we first search the pivot index. After searching the pivot index, we ran the binary search from 0 to the pivot minus 1. Okay, and for the first index, for the first sub array, if we find our target there only, then it will return true from there. If it doesn't return true, it will go to this second array, second sub array here. Okay, if answer is not found, then it will go there, and start will become pivot, and end will be end minus 1. Sorry, end minus 1, that is equals to 7 minus 1 equals to 6. Okay, so then here also we'll do the normal binary search. If we got the target, it will return true, else it will return false. Okay, so that was all. Hope you liked this video. Thanks for watching.